Okay, in this lecture we'll talk about trigonometry, very basic things. What we are going to go over, we're going to go over the definition of pi, why pi appear in this, like whenever we have a circle or angle, we see pi. By the way, I'm going to split this lecture to 3 parts, each part approximately 15 minutes, and after each part you have to solve a problem related to that part. In second part of the lecture, so this is the whole lecture. These 4 are for the whole lecture. In this piece, we are going to talk about the arc length. If we have a circle and we want to calculate the length of this arc, of course, we need to know theta, the angle, and we need to know the radius. Then we are going to solve it. In this part, how to calculate the area of the sector. If we have pizza slice and we need to calculate this area, again we need angle and we need radius. And the last part we're going to talk about in this part about right triangle. So if we have an angle theta, let's say acute angle, then we have 3 sides. This one we call it opposite, this one we call it adjacent, and this one I'll go in detail, and this one we'll call it hypotenuse. We'll try to find some relation between these sides. Application in real life, one of which, like why we study these things, one of which something we call it measuring wheel. This wheel is used to measure distances. We see it in construction field. It's more convenient, better than the like the tape or the meter or whatever, which is this one. The other application is the windshield, wiping the glass or the windshield of the car. We need something like that, and then engineers, they need to know the area, they need to know the length of the arm and the angle of each arm, how much should one go, so they are not going to exceed their limit. We are going to solve some problem related to these things. Let's start with the pi, from where we get pi. Here, see, any circle, this is a general. If you divide the circumference to the diameter, then this is always constant. That constant approximately 3.14. We call it pi. That pi comes from here. So it's defined like division of or ratio circumference to the diameter. Now if we cross multiply, let me put 1 in here, and then I multiply this by this by that, and then I solve for the circumference. So the circumference equals to 2 pi times r. Okay, now there are 2 units to measure the angle, one of which called degree, and one of degree we give it this little symbol, and the other one called radians. How they relate to each other? Pi, it means 314 radians, equivalent to 180 degrees. That's the only thing you need to know, and then you could convert between these 2 units. Here, let's convert 7/8 radians to degrees. We could do it with this way. Make 2 columns, one of them call it degrees, the other one call it radians. And in radians, if I have pi, in here I have 180. Then I'll come to the question. My question in radians, so I put this number under radians, 7/8 pi. How much is this? X. And then cross multiplication. This times this equal this times that. X equals to, pi will go down, and then 180 times 7/8 pi, and then you'll get this. Do this one. It's the same technique. Go to next. Here we do the opposite. Degrees is given, same thing. Radians, degrees, 180 degrees, pi in radians. My question given in degrees, so I put degrees under degrees. How much in here? X. Cross multiply. X equals to the coefficient is 180, and here 150 pi, and then you're supposed to get this number. Okay, try to practice them, even they look easy. How to calculate the length of an arc? The length is just equals the radius multiplied by the angle, but the angle must be measured in radians. So radius times angle. In this question, R is given, I think it's 5.2 centimeters. The angle is given, and the only thing you need to know, just apply this in here and you get what you need. As simple as that. Go next. In this one, see, this is our relation, has 1, 2, 3 variables. I just want you to play a game how to express one in terms of the other. L equal R times theta. How about theta? Then we need to divide both sides in here by R. And then this R would go with this R. I'm going to liberate theta, and what's left is L over R, which is this. And that's it. Okay. One of the application. The wheel that this guy is using has 25 centimeter in radians, which is 0.25 meter. Okay. And the distance we need to measure is 30 meters. Look like we know the distance. Then what do we need to know in this? We need to know the number of full rotation or revolution. This wheel is going to rotate how many times? If it's integer, we'll say, okay, this wheel is going to rotate 10 times. If it's not integer, for example, 10.2, then the question says convert this piece to degrees. So our answer will be two pieces. First, we need to know how many revolution, and this small piece need to be converted to degrees. Back to our lovely formula, length equal R times theta. Solve for theta as we did. L divided by R, it should be same units, meter, and then we'll get 120 radians. 120 radians, we need to convert it to revolution. Revolution, it means full circle. One full circle, one full revolution equal to 2 pi radians. That's why in here we divide, we divide by 2 pi. That's the reason. And then look how much we get. We get 19 full revolutions and 0.11 of the revolution. And the question asks us, if there is a fraction, convert this fraction to degrees. How to convert it? Easy. Degrees revolution. One revolution, 360 degree. 0.11 revolution, x. And then this times that equals to what we're looking for. Okay? Let's go next. Area of the sector. How to calculate the area. Area of a sector, in general, the area equal half of the angle multiplied by r square. This theta is the angle facing the arc. So if you want to calculate the area of a full circle, then theta should be 2 pi for a full circle. So if I put A equal, instead of theta, 2 pi divide by 2 times r square, I get pi r square, which is the area of a full circle. Now, it doesn't need the question, not always they ask about full, they ask about a piece of, again, it is the same formula, the area equal theta over 2 times r square. And the only thing you need to substitute theta. Theta must be expressed in radians. And that's it. Okay. Look in this example. In this example, let me zoom in so you could see. We have, let's say, this is a land, or you could switch this meter to centimeter, and you could visualize it as a pizza slice. So more interested. So the radius is 55. This radius is 55 also. It's the same. And what's given? Let me see. Oh, what's given in here, the total length, this plus this is given. It's 170. So this is easy. If I subtract 55 and 55, because this and that, then I'm going to get the length of the arc. So the arc length equals to 66 meters. Okay. Now the area. How to calculate the area? Now we have a lot of given in here. The area, as I said, equals to theta over 2. No, here I'm using I'm not using theta. Let me tell you how is this. Okay, theta over 2 times r squared. That's the general. Let me derive this formula for you. So I will write the 1/2 by itself, and r squared, I will write it r times r, and this theta coming here. So look what we have. R times theta, this is L. So that's 1/2 r L. Okay? So in our case, we have r is given, L, we get L. That's in here. That's what we're doing. This is the way we calculate theta. That's so in here solved in two different ways. That's theta, 1.2 radians. By just applying, we have L, we have radius, we could get theta. And then we apply 1/2 r squared times theta. We get this. What I want you to do is this other way. 1/2 r times L. You have r, how much is it? 55. And you have r theta, this is L. You need to find the same answer. Okay? What's in here? In this one, oh, this is also some general things. So area is capital A, something, it's not given as a number. Let's see, sector with an area of a circle with, the radius is given. The radius equal to 2 units, 2 centimeters, 2 meters, doesn't matter. And we need to solve for theta. Of course, we need to solve for theta in terms of the area. So we start with this, and then r is 2, so this will be 2 squared, that's 4. 4 divided by 2, then this is just 2. Then I'll get from this area equal to 2 theta. That implies theta equal area over 2. And that's it. In the next one, I'm not going to solve this. So this is a windshield problem. I gave you radii. I'll give you angles in here in degrees. Pay attention to convert it. And I'll ask you to do something. So this is your part. You are going to do it. And then click for the next part of this lecture. I'm going to stop in here. Good luck.